math in code, you are going to build a number detector, a prime number detector. It detects that a number is a prime number and also lists the factors, or it tells you that this is not a prime number in simple way. Let us begin right away. So what is the program going to do? So you're going to write it in Python. Get out your computer or your laptop and you write it. You'll see things coming out so cheaply. Programming is so cheap work. So program to check whether a number is a prime number, it's a prime, and lists its factors. Imagine if you have such a simple program, you no longer be bothered whether the number is prime or not prime. You just put in your system and it tells you that this is a prime number and these are the factors. So we begin by saying we have our variable called number. So we ask the user to input their number. So input their number, we tell them enter any number. So you don't need to know. So the system will help you know. Enter any number, that number that you want. Then we have the factors. So factors are initialized as a list. Then what do we do next? We are going to find all factors. So the logic behind all factors of the number. So the logic behind find is all factors of that number. So we come and say for I in the range. So the range of 1, then the number plus 1. So that's a for loop. So if that number, when divided by I gives us a remainder 0. When divided by I gives us a remainder 0, we call that a factor. So for a number to be a factor, it does not give a remainder when one number divides it. So append, so we attach our number to the factors. So after there, what do? We print. So what are we printing? We come and tell you that factors of who? So factors of the number that you have entered. Factors of the number. So the number that you entered are what? Are factors. So you put in the factors. After there, simple lines of code. After there, we go ahead to check. So in code, this one we call it commenting. You write what the code is going to do. Check if the number is a prime number, and then you write and say if number. This is how we check that the number is a prime number or not. If a number is greater than 1 and the length of the factors, the length of the factors are only 2. If they are only 2, it means that's a prime number. So as simple as this is, that's how you check that the number is a prime number. So a prime number is that number with the 2 factors, 1 and itself. So we come and say, therefore, this confirms that the number is a prime number. The number is a prime number. So it's a prime number. Else, if they are beyond, else, as if you are talking English, else print. What are we printing? Print that the number is not a prime number. The number is not a prime number. Now, as simple as this number checks that the number is a prime number and gives you the factors of that number. So now we begin by checking. If you run the code, you enter the number, for example, 3. 3, it will tell us that factors of 3 is 1 and 3. And 3 is a prime number. As beautiful as that. Now when you enter another one, for example, 5. 5 has 1 and itself is a prime number. Now imagine you enter 4. 4. 4 has factors 1, 2, 4. 4 is not a prime number. Now imagine you enter a number, any abnormal number you don't know. So if you enter another one like 67, it will tell you that 67 is a prime number. Factors that, and it is a prime number. Now if you enter like 20, so any number that you want, it tells you the factors and tells you that 20 is not a prime number. As simple as this, you have built what we call prime number detector. Don't forget to like. If you haven't liked the video, subscribe and click the bell icon such that you get notification when I upload a project like this. Yeah, get a computer, try it out. You'll see things coming out easily. We meet in the next. Thank you.